Okay, welcome back everyone. So today we are going to be looking at arithmetic series, okay? Similar to arithmetic sequences, but this time arithmetic series is a list of numbers separated by an addition sign in which each term is found by adding or subtracting the same number to the previous term. Okay, so very similar to an arithmetic sequence, this time though it's separated by addition signs. So I'll give you a couple of examples. So first example is 3 plus 5 plus 7 plus 9. Okay, so obviously the common difference here is a plus 2. We could also see something like this. In which we're decreasing the value of our terms. Okay, so obviously the common difference there is -4. Okay, so what we're looking for this time is we're going to end up using these series in order to determine the sum of a pattern. Okay, so in order to do that, first thing that we have to do is to state some formulas. Okay, so we need to state, we need a formula obviously to find the sum of this. So the formulas that we're going to use, there's going to be two different ones. And first what I'll do is I'll identify the variables and then we'll put these formulas together. So you're going to notice a lot of the same variables as before. So T1 is obviously that first term. Okay, and then we've got N is the number of terms. D is the common difference. Then we have Tn representing the last term. And something new is Sn, which is representing the sum of n terms. And again, that n can be any number. So if we're looking for the sum of 20 terms, n would equal 20. Okay? So the first formula is given as S subscript n equals n multiplied by T1 plus Tn, all divided by 2. Okay, and the second one is Sn equals n square bracket 2 multiplied by T1 plus n minus 1 multiplied by d, all of this divided by 2. Okay, so this first one here, we are going to use when we have the first term, the last term, and the number of terms. So here we must have first term, last term, and the number of terms. Okay, and for this second one, we're going to use this when we don't know the value of the last term, but we know how many terms we have. So we don't know what Tn is, but we know what n is. Okay, so these are the two different formulas that we're going to be using throughout this chapter. So first example, working with fireflies. Okay, so basically we're told that a particular firefly flashes twice in the first minute, 4 times in the second minute, and 6 times in the third minute. We want to determine the total number of flashes for this firefly in 42 minutes. Okay, so we're just going to use the information that we know and substitute it into this formula. So if we start off, we know that in the first minute it will flash 2 times, the second minute 4 times, the third minute 6 times, and it will continue. Okay, and we want to go all the way up until the 42nd minute and determine the total number of flashes. Okay, so we need to look back to our formulas and decide which formula we are going to use. Okay, we have the first term, we don't know what our last term is, and we don't know what the number of terms is, so we can't use that first formula. That means we have to use this second formula. Okay, and we're just going to substitute the values in here that we know. So, the sum of 42 terms is going to equal, we know n is 42, we know our first term is 2, we're looking for 42 terms, and our difference is 2. And we're going to take all of that and divide it by 2. When we simplify, we'll end up with 42 multiplied by 4 plus 41 multiplied by 2 divided by 2. Continuing to simplify, we get 42 multiplied by 86. And we're going to divide that by 2. And we end up with the sum is equal to 1,806. So that means that in 42 minutes, it flashes 1,806 times. Okay? So for the next question, this time we're given the sum of the first 2 terms of an arithmetic series, and then the first 4 terms. Okay? Then we want to determine what the first 6 terms are, and then what the sum is of 20 terms. So there's quite a bit of work that we have to do here. Okay? So first thing is to decide what we're given. Okay? And so we're given 2 sets of information for this particular problem. So we're going to have to substitute that information in twice. Okay? We're going to be working with that second formula again. And we're going to work with the first part of the question. So it says the sum of the first 2 terms of an arithmetic series is 19. Sum of the the first 4 terms is 50. So we're just going to work with that sum of the first 2 terms is 19. Okay? So we know that the sum of those 2 terms is 19. We know that there are 2 terms total. We don't know what the first term is. Okay? We haven't been told that. Again, we're working with 2 terms, so we substitute that in for n. And we also don't know what the difference is. Okay? We haven't been told that. So, simplifying this expression, we're going to cross out these 2's. And we're going to be left with a simplified expression of 19 equals 2t1 plus d. Okay? And what I'm going to do is I'm going to rearrange so that we have d on one side of the equation. Okay? So I'm going to leave d right here. And I want to isolate that. So I'm going to subtract 2t1 from this side and 2t1 from this side. So we'll be left with 19 minus 2t1 equals d. Okay? And the reason that I'm doing that is so that I can isolate one variable, because we're going to need to work with this same, do basically the exact same thing for the second part of the question. Okay? So the second part says the sum of the first 4 terms is 50. So we're going to use this same equation here. Okay? And this time we know that the sum of the first 4 terms is 50. The number of terms is 4. We don't know our first term. We know that our number of terms is 4, and we don't know our difference. So we'll divide that by 2, and then we're going to simplify. Ending with 50 equals 2 multiplied by 2t1 plus 4d minus d. And we'll continue to simplify. So combining the terms within here, we end up with 3d. So we should end up with 50 equals 4t1 plus 6d. So now what we need to do is take this equation here and substitute this in for D in the second equation so we can solve for our T1. So I'm going to do that on the next page. So we have D equals 19 minus 2T1. And then we had 50 equals 4T1 plus 6D. Okay, and that was just from the previous page. So we're going to take this value for D because D equals 19 minus 2T1, and we're going to substitute it into this D here. So we have 50 equals 4T1 plus 6 multiplied by 19 minus 2T1. And then we're going to simplify and solve for T1. So to do that, we have 4T1. We're going to distribute the 6 through to this bracket, and we get plus 114 minus 12T1. And then we're going to continue simplifying. So 50 equals negative 8T1 plus 114. We're isolating for T1, so we want to move this 114 to the other side. So we subtract 114 from both sides, and we end up with negative 64 equals negative 8T1. Solving for T1, we divide by negative 8 to both sides, and we get 8 equals to T1. Okay, so we can now use this information to answer the actual question, which is what are the first 6 terms of the series and the sum to 20. Okay, so what we can do is use this information here to help us find out what the difference is. So we know that's the first term. Okay, we can use this here and substitute it back into this equation up here to find out what D equals. So we would have D equals 19 minus 2 multiplied by 8, which is what we found for the value of T1. And continuing to simplify, we would have 19 minus 16, D would equal 3. Okay? So the first 6 terms of the series can now be put together. So our first term is 8. Then we know the second term is going to have a difference of positive 3. So that will give us positive 11. Then we're going to go to positive 14, 17, 20, and 1, 2, 3, 4, 5. This is the last one. So these are the first 6 terms. Okay, the last part of the question is we want to find out what the sum of the next 20 terms are. So in order to do that, we're going to use our original equation multiplied by 2 times our first term. We're looking for the sum of 20 terms, and our difference was found to be 3. So we'll divide all this by 2. Then we're going to simplify. So 2 can simplify with this to give us 10, multiplied by 16 plus 19 multiplied by 3. And when we work that out and punch that into our calculator, we're going to find that S20 is going to equal 730. So the sum of 20 terms is equal to 730. And that's all for this. The assignment is found on the page, and we'll work on this tomorrow in class.